Most Linux tutorials throw a bunch of commands at you and expect you to memorize everything. Unfortunately, that's not how people learn. In this tutorial, I would be teaching Linux specifically for DevOps and cloud engineers without any of the fluff and making you actually understand the why of Linux rather than memorize commands. This course is going to be beginner friendly, and it doesn't matter what background you're coming from, non-IT background, tech support, it could be even any other IT background and you're trying to brush up on Linux. So there's no prerequisite for this course. I would start with the basics, hardware, software, but I'd go fast just to make you understand it. If you are trying to follow any of these career paths and you are trying to be a DevOps engineer, cloud engineer, site reliability engineer, infrastructure engineer, platform engineering, all of these cloud major roles, Linux is really the starting point. And I'm making this course actually really easy. And I guarantee you, this would be one of the easiest Linux video you've ever watched on the internet. And it's free. All 5 modules are free. All you have to do, get your pen and paper, take your notes, and once we get to the tutorial parts, actually start practicing. And the reason why I'm putting out this course is because I think a lot of people memorize Linux and get it wrong. And it is a course that I wish was out there when I started my journey in IT 10 years ago. It would be 5 modules. In the first module, we would go over the fundamentals of operating systems, understanding why operating systems, hardware, software, Windows as an operating system. Then, which this first module we would cover today, we would understand the Linux operating system and the different distributions of Linux. And by the end of today's class, we would set up our first Linux virtual machine. Exciting. Now, in the second module, which should drop tomorrow, we would be talking about the folder structures in Linux. Whenever you set up a Linux machine, it comes with out-of-the-box folders, and you need to understand these folders and know where they are located and what the uses are, so that whenever you are troubleshooting a Linux system, you actually know where to go look and fix it, right? So, and in the third module, we would cover user management, file management, and working with the VI editor. In Linux, these are important aspects or components. If you are working with Linux, 90% of the time, you would manage users, you would manage a whole lot of files, and editing and modifying these files, you would use the VI editor. We will talk about file operations. Like I said, you work with a lot of files and configurations, and there's different commands and tools that you would use to be able to perform different sorts of operations on these files that you work with. And in the last module, we would cover process management, disk management, network management, and also monitoring. Then I intend to add 2 bonus modules. We would write 2 basic shell scripts in Linux. For your understanding, with these shell scripts, you could take them and run, and you could start writing. You could become a pro at shell scripts. And I would also include an interview question and answer section for Linux. So now let's start with operating systems. Why operating systems before we even talk about what an operating system is? I know most of you understand what an operating system is, but I'm trying to make the course beginner friendly, so bear with me. So let's say you went to HP, right? Let's say you went to Best Buy, right? Or let's say you went on Amazon.com and you bought a laptop, you ordered a laptop. Let's say you bought an HP laptop, right? HP is the hardware component of the laptop. HP as a company and the vendor actually creates the hardware component of the laptop. And when they created the hardware component of the laptop is being assigned with memory, CPU, disk, and also with a network interface card, right? So, but you, the user here, who's trying to use the laptop, unfortunately, you cannot access these resources on your HP laptop directly. Even all the programs that run on your computer, for example, Microsoft Word for you typing your documents is an application. Google Chrome is an application. YouTube, where you are watching this video, it is an application. Your application also is fighting for resources on the hardware because your application runs on the hardware. So what happens is we need an intermediary to be able to communicate with the hardware, which is why software comes into the picture. Now, in this case, software would be Windows. HP laptops do run on Windows operating system. So that is the software. If you take out the Windows operating system on an HP laptop, the laptop is as good as useless. The method of communication, right, from you or your applications to the hardware is either through two methods. You would either use a CLI, which is command line interface, or you would use a GUI, which is graphical user interface, GUI. So GUI in Windows is like when you're clicking all around. So, and Linux, which is the command line interface when you type in commands. So this is how you make this is how you interact with your hardware components. And without the software, right, without the software component on your laptop, you will not be able to make system related calls to the hardware. So software is responsible really for four things. It's responsible for process management, disk management, network management, and also memory management. That is what software is used for. Now, like we said, Microsoft is software. The hardware is laptop. The official definition of an operating system is an operating system is the main software that runs on a computer or a phone managing hardware and applications. That is what a computer operating system is. Now, is Linux the only operating system? No, we just talked about multiple operating systems. Let's say, for example, you're using a Google Chrome phone or your Google Pixel phone. That phone, the hardware component was developed by Google, which is the hardware, and the software component of the phone is Android. That's how software works. Without the software component, hardware is basically useless. The most common operating system is Windows because Windows is user-friendly. We have Windows, we have Mac or Apple, like most of you guys use as well, and we have Linux. Now, the question is, why do most companies use Linux? Now, Linux actually came out in the late 90s, right? And it was developed by someone called Linus. And Linux wasn't actually the first operating system. Windows was out before Linux. But the reason why Linux was created is because every time programmers or application developers back in the day in the 60s and 70s, whenever they were developing their applications, right, they faced this problem here, all of this scenario. Whenever they developed their applications, it was hard for them to make system-related calls to the hardware components that existed at the time. So Linux was developed to solve this problem. So with Linux, it is very friendly with programmers and developers. It's very safe. Linux is safe and secure. And first and foremost, Linux is open source. What does open source mean? It means anybody can download the official code of Linux and make modifications to it and customize it to their liking, add a whole bunch of security features or extra features, and you can make it yours. It's open source. That's why a lot of companies like it. And also, Linux is super fast. Think about it. Sometimes, I know, guys, like imagine using your regular laptop or phone for your regular day-to-day stuff, and sometimes it runs slow. Now think about a company hosting applications like enterprise applications, like all these apps you are using on your phone, Uber, Google, DoorDash, Amazon. Listen, they have to run on Linux. That's why 90% of companies run Linux in production, because it is fast, it is safe. Now, let's proceed with understanding the structure of a Linux system. We would do that by understanding the main components of a Linux system. Kernel is actually the heart of a Linux operating system. Look at it as the engine or the motherboard of a car. And the kernel is responsible for basically four things. The Linux kernel is responsible for four things. It's responsible for process management. It's responsible for disk management. It's also responsible for network management, and is responsible for memory management. So hardware could be basically any component where you install Linux on. So Linux could be installed on any computer. You could run Linux on an Apple computer. You could run Linux on an HP computer. You could run Linux on any computer. So that is why we have hardware at the bottom here, right? And we have the kernel that sits on top of hardware, and the kernel is responsible for process management, disk management, network management, and memory management. It makes these calls. And on top of the Linux kernel, we do have a whole lot of system libraries. Now, these system libraries, packages, or utilities are what make Linux a very rich operating system, which is highly preferenced by developers, by software programmers and developers. And then on top of the system libraries, we have CLI or GUI. So CLI is the command line interface, which is basically how you send calls to, which is basically how you interact with your kernel and the hardware component of your computer. So whenever you install a Linux system, you would have an option of either setting up a graphical user interface or CLI. I encourage a lot of you guys, please avoid using GUI if you are trying to get into tech and really work, because if you practice, I see a lot of people practice Linux a lot, and when they set up their first computer, they still have GUI on it. It beats the purpose. That's really one of the reasons why Linux is super fast, because Linux stripped out all of the GUI component, which makes it really fast. Whenever you are working on a Windows computer and you are clicking around and pages are loading, all of that stuff is what slows down your computer. I'm not saying you should stop using it. I'm just explaining to you the why Linux is favored and why it is fast and why it is favored. Now, let's talk about the various distributions of Linux. Just like we talked before, Linux is open source. What does that mean? Anybody can download the official code of Linux and make modifications and have their own version. Unlike Windows, you cannot go take a copy of the software that the code that the Windows operating system was and modify it and have your own version. You cannot do the same thing with Mac. You cannot do the same thing with Android, because these are enterprise softwares that are licensed and they are being owned by the vendors. But with Linux, it's very possible. That's why you hearing about systems such as Ubuntu, Fedora, Alpine, CentOS, Red Hat. That's why you keep hearing of all of these different distributions of Linux. What it means is that these companies, right, basically took the official flavors or copies of Linux, of the Linux code, and made modifications to it, and they had their own enterprise copy and they distributed it. That's what it is. So we'll be switching and setting up our first Linux system. But before we do that, I don't want to come back to the blackboard, so I thought about explaining its concept right now. So when we set up our first Linux system, first things first, we would set up, let me see. So when we set up our first system, right, we would run sudo, the first command we would run is sudo apt update, right? But before we do that, I want to explain something about this command and why. Forget about the command. So let's say when you go buy a new computer, let's say when you bought that laptop at HP, right? When you go home, the first thing you want to do is to, if there is no Chrome or Firefox or Word on it, the first thing you would obviously do would be to start installing your programs on it, right? So apt is a packet manager utility that comes out of the box with Linux. Now, there's something in IT or tech that some people, if you are not coming from a technical background, you might miss it. So let me just explain it right now. Say, for example, right, whenever you are trying to download Chrome or Firefox or any package or any application from the internet and you look it up on Google, what happens is if you don't go to the official page where that application source code is hosted, that's how you get vulnerabilities and malware and viruses into your system. Now, Windows does not have a dedicated utility or packet manager to help you avoid getting bad dependencies or viruses onto your computer, because you could just go on Google and you could type, hey, download Chrome, and you click whatever link comes up. You don't know what you're downloading. The best way to do it is, let's say you want to download Google Chrome, for example, you have to go to the official website and download it. So Linux has a package utility that's called apt. And what it does is that there is a repository on the internet, right, where a lot of libraries and files and programs that are being used by developers on a Linux system every day. So rather than downloading, so what apt does, right? What this package utility does is it goes to the official repository of whatever package or software you are trying to download and gets the official copy, reducing the chances of you getting vulnerabilities or malware onto your Linux system. So this, guys, this is one of the reasons why Linux is so powerful. And whenever you are downloading packages, it's way much better using apt. I would still explain it when we run it, but I just thought I should explain it right now because I wouldn't be using a whiteboard. And in case the concept goes over your head, please shoot a comment and I would explain more, right? Now, in regards to setting up your first Linux machine, we would have two options. So I really love this one. If you could install WSL so you don't have a cloud instance. Let's say you cannot set up a cloud instance, you already used an AWS account, because we would set up two Linux instances, because I love WSL. WSL creates a Linux-like environment on your Windows PC. We would be using Windows for all of my tutorials on this series. And so you could run WSL -- install, right? So we are going to do it together. I'll show you. I'll do it with you, right? Once we run this, it would set up a, so you go to your command prompt, you right click on Windows, I'll do it. So just be patient. I'll do it with you. I'll show you how I do it. And we would run WSL install. It will install a Windows-like environment on our computer. And then after it installs that, we would also set up a cloud instance with AWS. The reason why I would set up a free account with AWS so we could get a cloud instance is because if you are trying to speed things up and get over with this and start rushing with studying cloud and DevOps, you could just set up your cloud instance. It's gonna help you. But you also need understanding. If you can set up both, hey, let's get it going, right? Set up both. So yeah, let's get it going. So on your Windows computer, you want to go here, you right click, select terminal. Once it opens up, just run WSL -- install and hit enter. See, downloading Ubuntu. So it's basically creating a Linux-like environment for my Windows system. Just watch, guys. You're going to see something. Installing Ubuntu. I might pause this part and just bring it back up to, hold on, I'll bring it back. Okay, so as we can see, WSL is done. Distribution successfully installed, can be launched to wsl.execute dash. So this is running it in the detached mode, -d. These are the little things we would be learning. Anyways, let me first, it says, this might create, I have to create an account. It's saying ICE is 1. Let me create a password. Thank God for Linux. Nice. Okay, user mode, no changes. Let's see. I see I'm in, right? I logged in. Now, guys, all right, so if you got here, just run sudo apt update, right? It's asking for a password. Okay, so guys, by the way, WSL would also work on your Apple or your Macintosh laptop. So you could do the same thing on your command prompt and your terminal. But if you want to set up a cloud instance, go to Google and just type this: AWS free account setup. AWS free account setup, right? I already have an account, but I want to show you how to do it in case you don't have one. So once you type that, go to the official link of AWS, aws.amazon.com/free. So you would create on, you would click on this link to set up a free account. It has prompts. It asks for your name, email, phone number, address, and it would ask for a credit card, but they won't charge your card unless you go over the free limits, and it's going to be free for 6 months. I'm not following this process because I already have my own account created. So once you create your account and log in, right, follow the prompts, you would get an interface like this, right? Now, once you get on this screen, just go to the search bar and type EC2. 1 second while this is loading. On the search here, you just type EC2. I'd explain everything as time goes, okay, guys? Under EC2, you could click on instances, right? Okay, that's loading. So we are going to launch our first instance. Oh, I had a Linux for DevOps that was deprecated. Let's just say launch instance, right? So you click on launch instance. The name of your instance, you could name it anything. Starting Linux, your name, you could name it anything. I choose to name mine Linux instance, right? Okay. Operating system, we have to select an operating system. Remember I said let's go with Ubuntu, right? Just like we did on WSL, we set up an Ubuntu instance. Now we are going to select, because it's a cloud instance, we are going to have to select the type of instance. We have T3 micro, T2 micro, macro. Don't select, just try to get a free one. Don't get one that you are going to pay for. I could get I personally want a T, I personally want, I want at least 2 GB of memory. Oh, that's 4, that's a lot. Okay. Guys, all of this is not important. It's just me. I just be extra with these things. Like, I can't stand slowness, but clearly it's slow. I have to kill a lot of programs on this computer. Now, key pair, you can create a key pair. Actually, let's create a key pair. I don't want to use things and then after you ask me, let me see, Linux instance. You don't have to create a key pair, but just create it. It's going to come handy at some point, right? Now, that is the key pair. It's going to get downloaded automatically, right? Every setting here, do not touch anything. Do not let it be at 8 GB. Let everything be the way it is and just come here and click on launch instance. That's it, guys. What's happening now in the background is Amazon is going to launch an instance for us. They are provisioning an instance for me right now, right? Or for us. Now, once we get this instance, what's the first thing we are going to do? We are going to definitely, okay, once your instance is launched, I could click here and go directly to my instance. I could go to the EC2 panel and click on my instance, but I know it's this. Same thing, it still takes me to the EC2 panel. Going back to instances and I could come here. Yeah, so I would go to my instance and I would connect to my instance. Just like we did with WSL, guys. The very first thing we did, you guys remember, right? You scroll down, go to connect with WSL. We first updated, got our instance up to date, which is the first thing we are going to do here. And how did we do that? Sudo apt update. Now, I know I'm not trying to get ahead of you, but if you have any questions, just so you sleep well, I don't want you leaving this class thinking, oh, but he said he's going to explain everything and now he's saying sudo apt update and he doesn't understand it. So sudo in Linux is basically sudoer when you are trying to run administrative commands as as an admin, because let's say updates, you don't want anybody to be able to do updates on your Linux system. So out of the box, Linux provision this system in such a way that not anybody can update. See, for example, if I just run apt update, right? See, apt update, right? It might say permission denied. What is it saying? Permission denied right there. You see, because I was going to be surprised because I don't have permission to do it. But if I get into super duo mode, right, now I could run apt update because as an admin, I have the right to update systems. But as a regular user, how do I know I could update systems? Just getting you guys to understand the concept. Don't think about it too much. We are going to continue from here, understanding from the next class, understanding the structures of this system, comparing it in tandem with this one, with our Windows system, and also with our WSL. Remember, we have WSL right here, and remember we do have our EC2 instance, cloud EC2 instance here. So whichever one you set up, whichever one you want to follow on this tutorial for, I got you. Stay tuned, and I guarantee you this would be so easy. Take care.